Hi everyone. So today we'll be learning experiment number 1, which is nothing but generation and detection of DSBC and standard amplitude modulation, that is called the DSBFC, using IC398 and LM741. Now these are the components required. IC398, which is 8-pin IC, and it is a sampling IC, and IC741, as you know, it is a operational amplifier, and we need some additional resistors and capacitors. Dear students, this is a circuit diagram of our required circuit. Here it is a 741 IC, which is acting as an inverting amplifier, and here you can see this is 398 LF398. As I told you, this is a sampling IC, so which has two inputs. One is M of t, another is minus M of t, and sampling frequency, carrier frequency is given at pin number 8. Now output is taken at pin number 5. Okay, so this is basically output is DSBSC. Even though IC is sampling IC, during on time of the carrier signal, M of t is selected. During other time, that is off time of the carrier signal, negative signal, that is minus M of t, sample is selected. Therefore output we are going to get the DSBSC signal as we require. Here you can observe the waveforms. So above signal is a carrier, then the middle one is the message signal, and before that what we are able to see is the modulated signal. So and finally, if you add the carrier to the DSBSC signal, you are going to get standard AM signal, also called as a DSBFC, double sideband full carrier signal. So dear students, once we get the DSBSC signal, that is V of t, and addition of carrier, so using two resistors here, 47 kilo ohm, we are going to get a AM signal. Once we get AM generation, so we can use the envelope detector to demodulate the signal, which consists of a diode, a resistor and capacitor. So output we are supposed to get as we require is a original sinusoidal signal. Now let us do it practically. So dear students, here we have two signal generators. So one is message, which is 2 kilohertz range, other one is the carrier, so which is around 20 kilohertz range. So above signal I am taking it as a message signal, and so below signal generator output I am taking it as a carrier, and so these are connected to my circuit here. So as first what is required is signal which is connected to the 741 IC. This is our 741 IC. So for that, so we have connected a signal, so M of t, and output I supposed to get at pin number 6, which is supposed to be inversion of the signal. Let us see that. Now you can see the message which is connected, original message M of t is here, and output is taken out of the inverter circuit. Let us check that in the CRO. You just observe here, you see that the yellow color line is the input signal, and the blue color line, what you are able to see, that's the inverted version of the input message. Now first part we got it, that is getting the minus M of t from the 74L1, we got it. Now the original signal is connected as M of t here, and inverted signal connected here, and I supposed to check these two at pin number 3 and 6, and at pin number 5 I supposed to get carrier, output, and pin number 8 it is a carrier. So pin number 5 is the output, which is nothing but a DSBSC signal. So let us check that part. So here is the circuit which is connected with the LF398 IC, which is seen here. So at pin number 3 I am connecting a channel 1, and at pin number 6 I am connecting one more. So as I mentioned, both are the inputs. So and at pin number 5 I supposed to get the output. Pin number 5 I supposed to get the output. So let us see that Let us visualize on the CRO. So you can see the original signal there, which is yellow color one, and the modulated one, you can see it is the DSBAC signal. So which very clearly you can observe W here, which is a phase shift. So and M here, M shape and W shape basically indicates that phase shift of 180 degree during negative half cycle, and phase shift, zero phase shift during positive half cycle. Now output of, so our circuit, that is 398, is the DSBAC. That DSBAC is further connected to a resistor and adder, where originally one carrier is connected to here and DSBAC, so that I supposed to get AM here. Okay, let me show that. So here you can see that connection at pin number 5 has come out here, and one more resistor is connected here. It is a junction point. So here the carrier which is previously taken, that carrier is connected, and output of this, so is connected to a CRO here, and the CRO will see. Now you can see wonderfully, because we added the carrier, the DSBAC has been converted into standard AM signal. You can see the standard AM signal which is available here. Let me stop and show you. Yes, now I have stopped, you can see. So there is a standard AM signal available here. Now I need to demodulate the same signal using envelope detector. Let me connect and show you. Now here is a diode acts as an envelope detector, RC network. I have removed a capacitor just to see the function of diode. You can, let us assume, so the diode is conducting only during positive half cycle, so we'll verify that here. So let me stop and show you. So dear students, you can observe here only positive half cycle are passed through the diode. Okay, therefore, so envelope detector is working perfectly. So now let me connect the capacitor, and so now capacitor has been connected, so across the resistor, so that it is a complete envelope detector. Now the output of envelope detector, so you can just see in the CRO. So charging and discharging is visible. So very neatly charging and discharging is visible for you people. Okay, so that shows that so envelope detector is working perfectly to demodulate the sinusoidal signal. So it looks as a original sinusoidal signal with some additional change in the phase. Okay, so and amplitude is different, so and the shape is same. Therefore we can say the signal is demodulated perfectly. Thank you very much.